In this video, I'm going to talk about arrow functions, which are a new way of writing functions in JavaScript. Typically, you'll write arrow functions when you want to pass a function as an argument to another function. Why? Because arrow functions are a handy way to write short, one-off functions in a concise way. Let's take a look at a couple of situations where we often find ourselves writing these kinds of functions. One example is when we pass a function to the for-each method of an array. Here, I'm passing a function to for-each that takes each item in the array of numbers, 1, 2, and 3, and multiplies the number by 2 and pushes the result onto a new array, evens. Another is when we pass a function to the setTimeout function. In this example, I'm passing a function that will display cookies are ready after 1 second or 1,000 milliseconds. Let's run these examples so you can see the output. I'll reload the page, and you can see that the result of displaying evens is the array 2, 4, 6. And you can see the message cookies are ready pop up as the timer event handler function is called. In both of these examples, I'm passing a function as an argument. In JavaScript, functions are first-class values, meaning that they can be assigned as values, passed as arguments to functions, or returned as values from functions. Until now, we've written all functions in the same way, with the function keyword and with the body enclosed in curly braces. But now that features from the ECMAScript 2016 standard have been implemented in browsers, you'll likely start seeing arrow functions replace some of the functions you're used to in these kinds of examples. So what is an arrow function? It's a function, but it differs from functions as you know them in JavaScript ES5 in two important ways. First, you write an arrow function using different syntax than you do for a regular function. Let's take a look at what an arrow function looks like. We'll start with the function that I passed to for-each to take each number of an array and double it, and push the result onto the evens array. To make an arrow function, I'll first remove the function keyword. In the arrow function syntax, we don't use the function keyword. Next, we write the arrow, which is equals greater than, between the parameter list, which doesn't change, and the body of the function. Finally, because the function has only one statement, I can remove the curly braces from the body of the function, although this is optional. Notice if you remove the curly braces, you also have to remove the semicolon at the end of the statement. Let's go back to the code and I'll rewrite both of the functions I've got using the new arrow function syntax. In this case, the arrow syntax will be a little bit more concise than using the normal function syntax. Notice again that because I'm not using the curly braces in the body of the function here, I need to remove the semicolon at the end of the statement in the function. I'll reload the page and you can see that the result is the same. Now let's do the same for the function I'm passing to setTimeout. This function has no parameters, so I just need to use the empty parentheses on the left side of the arrow. Again, I remove the braces and the semicolon. I'll reload the page and the function works as it did before. So why use arrow functions? Well, typically you'll want to use arrow functions to stand in for short, one-off anonymous functions. You'll save a little bit of typing because they can be a bit more concise, but that's not a huge deal. There's actually another important difference in arrow functions and regular functions that will be very useful in some circumstances, and that is this. Arrow functions are pure functions. They're never methods. And that means that the way that the value of this is handled in an arrow function in a different way than the value of this is handled in a regular function. Let's see how. To demonstrate, I'll create a beatbox object. This object has two properties, a string, sample, and a method play. Play has one argument, sequence, that will be an array of notes represented as strings. I'll loop through the sequence of notes and play each note using the value of the sample property in the beatbox object. To test the code, I'll create an array of notes, and I'll call beatbox.play and pass in that array, which will get passed to the seek argument. Before we test, I'll just quickly comment out our earlier code. All right, I'll save the file, reload the page, and you can see that the code displays that each note is played with the gong sample. So the code is working fine. Now, let's say you come along and you decide to replace your traditional for loop and instead use a for each method to iterate through the items in the seek array. So now the code looks like this. We call a function for each item in the seek array, do exactly what we did before. We'll use this.sample to play the note. Now, do you think that what will happen is the same as what we saw before? In other words, will you expect that the value of this will be the beatbox, so you'll see gong for this.sample? Let's give it a try. I'll reload the page, and you can see that the code no longer works. I'm seeing play undefined for each note instead of play gong for each note. So what happened? Well, what happened is that the value of this in the function we're passing to for each is no longer correct. To see that, let's display the value of this when we call the function we're passing to for each. When I rerun the code, you can see that instead of this being set to the beatbox object, now this is set to the window object. Why? Well, it's because of the way that JavaScript handles the value of this in functions that are not methods or obviously methods. We're passing a function to the for each method of the array, and in that function, the value of this is the global object window. This is just the way that JavaScript works. When you have a function that's not being called as a method, then by default, that function is actually called as a method of the window object, or whatever the global object is, depending on your JavaScript environment. So it's as if the for each method is calling window.function. And so, because this function is actually a method of window, the value of this in the function is the window object. So we basically lose the value of this when we call another function inside the method play. This issue has long plagued JavaScript programmers in precisely this situation. We have a couple of workarounds. A common pattern is to save the value of this before we call the function, and I'll do that here by saving the value of this in a variable called that. And then instead of getting the value of the sample property inside the function using this, I'll get it using that instead. That fixes the problem. When I reload the page, you can see that we're now getting the correct result. Another common workaround for this problem is to use bind. We can force JavaScript to bind the value of this inside an inner function, like we have here, by first calling bind on the function value. This returns another function value where the value of this is bound to the value of this in context, which in this case is the beatbox object. Again, this fixes the problem and we get the correct result. Now we have another way to solve this problem by using arrow functions. An arrow function is a pure function. It's a function that's never called as a method, either of an object that you make or of the window object. So when we execute the inner function, the one we're passing to the for each method, and we get to the reference to this.sample, what is JavaScript going to use for the value of this? Well, the way that JavaScript computes the value of this in an arrow function is with lexical scoping, which is how we find the value of any unbound variable in the body of a function. Using lexical scoping, we first look for a value for this defined in the arrow function. There isn't one. So we then look for a value for this defined in the context surrounding the arrow function, and we do find one. In the function play, which is the context surrounding the arrow function, this is defined to be the beatbox object. So that's the value we use for this in the arrow function. Remember that this is always bound to the object whose method we're calling in the method. So in the method play, which is the context for the lexical scoping for the arrow function, this is bound to the beatbox object. Now, when I reload the page to run the code, we can see that using an arrow function here has indeed solved the problem. So arrow functions differ from regular functions in two important ways: syntax and how the value of this is determined. Syntax is easy to learn, but remembering that JavaScript now has two different ways of treating this in functions is a little trickier. It'll take a little bit of time to get the hang of arrow functions in situations where you're using this. Now you might be asking, so which do I use, a regular function or an arrow function? Well, it really depends on the situation. Both arrow functions and regular functions have their place, particularly if you're concerned about the value of this. Arrow functions can sometimes be considerably shorter than regular functions to write, although not always. So it's really up to you which one you use. The key thing to know is that now JavaScript has two different kinds of functions: regular functions, which are always called as methods of objects, and arrow functions, which are never called as methods of objects. If you need a refresher on all these core concepts, then check out Headfirst JavaScript Programming. And don't forget to subscribe to our channel. And thanks for watching.